Hello guys, thanks for coming back again. If you are my subscriber and if you're yet to subscribe and you're new viewers, please click on the subscribe button and also on the bell beside it. That will notify you when we drop our wonderful and new videos. In this video, we are looking at the NECO 2022 Physics Practical Techniques, and these are the idea and the diagram and how the question actually goes. So let us go through the journey of the diagram and at the same time the question. We are provided with some materials here which we have arranged, and when the practical starts you get to see them. But let's point them out from the diagram and then go through the question so we can understand what we want to do. We have a G clamp here, and this hand actually is the edge of the table. Then this is a meter rule, of which the calibration on it is not necessary. We don't actually need it in the experiment. Then the G clamp used to hold the meter rule at the edge of the table here. Then we have the meter rule being extended to this point, and we have a string or thread here where we can hang masses, and we have a beaker filled with water here, and we have a pointer, and this pointer is made up of optical pins attached to this meter rule by means of plasticine. Actually, we don't have a plasticine here, we make use of a tape. And at the same time, we're going to maintain the position hand all through the experiment where the thread is going to be located, and we're going to have another retor stand holding a meter rule, of which the calibrated face is going to face the pointer, and that is where we take our readings from. So now we have to hold it in such a way that the face will not be closed, and the pointer will be able to take any reading if possible. It's taken from the points where the retor stand held the meter rule. So now, and this is distance x, that is from 0 to the point where this pointer is hitting or touching. So our distance s, we're going to take a reading of x from 0 down to where the pointer is touching. So that is how to take our distance x. Now let's go through the question and see how it's being created. You are provided with G clamp. I think you've seen that in the diagram. 2 meter rules, and I think we've seen what the 2 meter rules are used for: retor stand, slotted masses, and other necessary materials. Arrange the materials as shown in the diagram above. Measure and record the distance x naught when no mass is hanged on n. That means without any mass being hanged here, we're going to take our reading of x, and that will be x naught. So in this case, let's move on. Suspend the mass hanger of n equals 50 grams at point n in the air. That means without the beaker of water there, we suspend in the air. Then, and this should be 5 centimeters away from the end of the meter rule, which means, according to the diagram, let's take a look at this. According to the diagram, we are going to place this point n 5 centimeters away from the edge of the meter rule, from the end here. So we're going to place it 5 centimeters away, and that is where we're going to be hanging our masses. So now let's proceed with the question. So we are told to suspend the mass hanger of 50 grams at point n in the air, 5 centimeters away from the end of the meter rule. That means we are going to, I think I've explained that, 5 centimeters away from the meter rule, and record the corresponding distance x. We are going to determine our distance x at that point. Now, the next is suspend the same mass m equals 50 grams at n in water. Now, that is when the beaker is available there with water. Then maintain n all through the experiments, and measure and record xw. So xw is actually the distance x when n is immersed in water, and it should be totally immersed according to the diagram. So now we are told to evaluate capital X equals x minus xw. We are going to evaluate that, and at the same time we evaluate x raised to power the negative cube. So that is the negative cube of x. We should evaluate that. Then we repeat. Let's move on. So we are told to repeat the procedure for n equals 100 gram, 150 gram, 200 gram, and 250 gram. Can we see that? So now we are also told that evaluate x raised to power minus 3, that is the negative cube of x, in each cases. So we are going to evaluate that in each cases. So let's go to the remaining procedure here. So tabulate your readings. So our readings, we're going to make a table for it. We are tabulating our reading, we're making a table for that. So then the next is what? Plot the graph of x raised to power minus 3 on the vertical axis. That is this x raised to power minus 3, that is the negative cube of x. We're plotting the graph of that on vertical axis. Plot that of m on horizontal axis. So m is going to be on horizontal axis. So then determine the slope s of the graph. So after plotting the graph, we determine the slope of the graph, and then we move on. Evaluate v equals 150 x, that is 150 times the slope. We are evaluating 150 times the slope, and that will be equals to v. And at the end, we state two precautions to obtain accurate result. So now let's go through the experiment. Okay, these are tables. I think the table has been made already. So I have the serial number, the mass, all from 50 to 250, and we have the distance x to be recorded here, distance xw to be recorded here, and distance x equals x minus xw to be recorded here. We have x raised to the power minus 1 over 3. X raised to the power minus 3 to be recorded here. So now let's go to the experiment so that we can fill up our table, plot the graph, and see what happens. Okay, this is the setup. I'm going to take the camera around it so you can see how it is being set or done. So now let's go through it, starting from the G clamp side. As you can see, this is the G clamp holding the meter rule right here. So then that goes. Then you can see I'm using this black tape as in place of plasticine, and this is exactly 5 centimeters away from the edge here. So and look at the pointer. This is the pointer which I use my optical pin for, and we take our readings directly from this face downward. So, and the beaker of water is also right here. The beaker of water is going to be here. This is the beaker of water placed on a particular stool, as you can see the setup now, so that when we hang the mass, it goes straight into this, and when we want to hang it in here, we remove this so that we can take our two readings all together. So now we'll start the experiment by recording or knowing the distance when no mass is hanged. That's distance x, that is x naught. So now let's go through that now. Let's try to read that now from the face. So no mass is hanged right away. So if we can just read through, let's try to read through that. What is the distance, and avoid any oscillation. So by taking that, I can have this is 9.5, and that will be recorded in 2 decimal place. That will be recorded in 2 decimal place. So I'm having 9.5 as my x naught. 9.5 as my x naught according to heat now. So now the next thing is to hang the 50 gram mass in here. So this is our 50 gram mass with the mass hanger. So let's hang in air and see the new distance. Make sure it's balanced before you take your reading. Make sure it is balanced before you take your reading. So I'm having, avoid any oscillation. So I'm having 12.6. 12.6, and that will be 12.60 in 2 decimal place. So now that is in air. So now let's take the measurement in water. Let's take the measurement in water. So let's put that, let it be immersed in water and see what happens at the end. So I'll remove this first, put my water. Can you see that? Then try to place it. So I think I need to raise this up more further so that it can be immersed in water very well. So let me get an alternative for that. So if I raise that up, so it can be immersed in water totally. So now I'll take my reading from there. I am having 12.3. 12.30. So that was what I'm having. So we have done that. So the next thing is to increase the mass. The next is to increase the mass to 100. So in order to do that, I get another 50 gram mass. 50 gram mass. That is making 100. Then I hang it again. So that is in air. So let it be stable before you take your reading. So let's avoid the oscillation. So I'm having 15 points. Okay, the reading should be 15.8. 15.80. So that is in 2 decimal place. 15.80. So now let us put the water and see the new length. Okay, now it's in water. So let's see the distance now. Wow. All right, I can see that is getting stable, and this is around 15.1. 15.10. That is it. Now the next is to increase the mass to 150. Increase the mass to 150. So to do that, I had a mass of 150, making 150. So then I measure in air. So when I measure in air, I'm having, let it get stable. So let me take my reading. So try to avoid parallax error when making use of this. So you check very well to ensure that you take your reading accurately. So we have 19.00. I'm having 19.00 here. So let me just check the reading myself. I mean very well. Okay, 18.9 rather. 18.90 rather. So we have 18.90. Then let's try to put it in water and see what happens. So when I remove this, put this, then so this is mass 150. So we have record the value in air. So let's record the length now in water. So let's check that. Let's check that now. Okay, I'm having 17.9. 17.9. So that is 17.90. All right. So now let's move to the next. That is 200 gram. So now we are going to 200, just like I've said. So for 200, what do we have? So we ensure that it's stable before we I can actually remove this if it's going to affect. So for 200, we have Let's move it closer. Okay, let's say 22 on dot. 22 on dot. So let's put it in water and see what happens. Yeah. So that goes to 20.5. 20.5. So lastly, to the mass of 250. And for our 250, I do not have enough 50-gram mass, so I have to join 2 of 20s with 1 of 10 together and then make use of that. So let's see the response of that to the experiment. So that is my 250. Wow. Ensure the pointer is straight so you can get your readings accurately. So you move that closer so you'll be able to get the reading correctly. So yeah, I can see 20. Okay, is yet to balance. That is 25.0. 25.0. So then we go for heat in water. So in water, what do we have? Oh no, that is, the beaker is too small. Yeah, so we can put it this way. So that is 23.4 actually. 23.4. So that is how the experiment is being done. Let's look at the table. Now we are meant to evaluate x minus xw. So by doing that, I will have the first one to be 12.90 minus 12.50, and that gives me 0.4 straight away. So I'm putting that in 3 decimal places, 0.400. So evaluating negative inverse of that, so negative cube of that, so I'm going to have 0.400 raised to power minus 3. So that gives me 15.625. 15.625. So that is the value. Then we have the next one to be 15.80 minus 15.10. So that gives 0.700. So by evaluating 0.700 raised to power minus 3, so that gives me 2.915. 2.915. Okay. I think I need to confirm this. 0.400 raised to power minus 3. Okay, 15.625. That's correct. So now let's go for the next one. 15 points. Okay. Okay. Now 18.90 minus 17.90. So I think that is 1. So that is 1.000. So, and 1 raised to power minus 3 is absolutely 1.000. So now the next is 22.00 minus 20.50. I think that is 1.5. So that is 1.500. So using that 1.500 raised to power minus 3. So that gives me 0.296. 0.296. So lastly, we have 25 minus 23.40. So that gives 1.6. 1.600. So 1.600 raised to power minus 3 raised to power minus 3 gives 0.244. So that's our table. And don't forget our x naught is 9.50. So that is x naught. So we have gotten our x naught on our table. So the next thing is to plot the graph. So now let's plot the graph, get our slope, do the evaluation. So we have the table here, and this is our table. And actually I've chosen a scale for our table. On M axis we are using 2 centimeter to 25 gram. On x raised to power minus 3 axis we are using 2 centimeter to 2 centimeter raised to power minus 3. And the title of the graph is graph of x raised to power minus 3 against m. So, and this is our table, and x naught and everything. So let's go to the graph. So by the virtue of the scale we choose, I'm going to have my m axis line here, and I have my x raised to power minus 3 axis here. So which I will number, this is 25.0, that's 2 centimeter, and I'm going to have 50.0 here. So the next is going to be what? That is 75.0. So now let us number that all through. So I have 75.0, then I have 100.0, then I have 125.0, 150.0, then I have 175.0, then I have 200.0, then 225.0, then 250.0. So now we need to put our y-axis now. So, and I think we said we use the scale of 2 centimeter to 2 centimeter raised to power minus 3. So which means each 2 centimeter I'm going to have 2, 4, 6, 8, 10, 12, 14, 16, 18. Good. So, and you can actually put that in 2 decimal place: 0.00, 4.00, 6.00, 8.00, 10.00, 12.00, 14.00, 16.00, and 18.00. So now the next thing for us to do is to plot up the graph. So now for 50 gram we have 15.62. So, and to locate 15, and this is 14, I just calculate about 5 lines away from 14 upward. So that is 1, 2, 3, 4, 5. So this is my 15. Then if I'm to calculate 15.6, I'm going to read each box, half of it is what? 0.1. So I go 15.2, 15.4, 15.6. So I have my 15.6 here. So this is my 15.6 here. So let's move on. Then the next is to check 100 gram to 2.9. So this is 100 gram. Okay, oh sorry, this is 25, so I have to make an adjustment. We are having 50. So let's trace that to 50 actually. So this is 50. So this is 50 to 15.6, 15.8 and 16. So now let's move to 100 to 2.9. So we have 100 here. So we trace it to 2.9. So, and this is 2. So this is 100. I have 100. This is 2. Then 2.9 is going to fall here. 2.6, 2.8. So 2.9 will be around this region. Sorry, this is 200. So we have 2.2, 2.4, 2.6, 2.8,
So 2.9 will be at the middle here. 2.9 will be here. So that is 2.9. The next is to take 150 to 1.00. So this is 150. So I will just need to count 1, 2, 3, 4, 5. So that's 150. I've just done 150 to 1.0. So we have 200 to 0.29 as well. So this is 200 to 0.29. So we have 0. This is 0.2. So 0.29 will fall around this region. Or let's say 0.3 actually. So it falls around that region. Then we have the one of 250 to 0.24. So this is 250, we go to 0.24. This is probably 0.2. So straight away we have this. So now we are done. Look at magical how the graph goes. Let's still go with that 3. Okay, now it's a negative slope and I'm having intercept on y-axis, so I can record the intercept on y-axis even if it's not required in the question. So I just have to record it. So now I've done this, so let's just determine the small slope of the graph. So let's determine the slope of the graph right from here. Okay, I can take that from here. Then down to this point. So I have the slope of the graph here. So here is going to be change in s cubed, x raised to power minus 3 rather, and here is change in m. So reading that out, we say slope s equals change in x raised to power minus 3. And don't forget that x raised to power minus 3 is capital. So, and then all over change in n. So for x raised to power minus 3, to find the change, I'm seeing here I'm having 2 points. 2.3. So 2.3 with 0.4. Sorry, with 0.4. So I have s equals 2.30 minus 0.40 over, then the next I'm having 200 here and I'm having 25 here. So let's use 200 minus 25. So and that is yes. So now subtracting that, what do I have? 2.30 minus 2.3 minus 0.4. So that gives s equals 1.9 over. So then I have 200 minus 25. So and that gives me 175. So the slope of the graph is going to be what? 1.9 divided by 175. So and that gives me 0.012. And what will be the unit of the slope? Don't forget the unit of this is centimeter raised to power minus 3 all over n. So which means I'm going to have centimeter raised to power minus 3 per gram. So that is the unit of the slope, centimeter raised to power minus 3 per gram. Yeah, that is the units of the slope. Now let's go ahead for the remaining calculation. So we're told to what? That's question question x. Why the slope is question ix. So for question x, we are told to evaluate v. V to be equals to 150x. So to do that, that's 150 times 0.012. So and that gives me 1.8. And what will be the units? So still the units of their slope. That is centimeter cube per gram. So and that is the unit of our slope, and I mean the unit of V given to us. And lastly, we are told to take two precautions to obtain accurate result. Number one, we avoided parallax error in making use of the meter rule. Then you ensure that the G clamp held the second meter rule firmly at the head of the table. Then we also ensure that the masses are immersed totally in water. So those are the precautions we need to put in place. Thanks for watching my video. Please subscribe to the YouTube channel. It's free. Share our videos. Then you're blessed. Thank you.